Hello friends, very good morning. Myself Dr. M.H. Annaya, and in today's video on the development of lateral surface of a triangular prism, the question reads like this. A triangular prism of side 30 mm and height 60 rests on HP on one of its triangular faces with a side normal to VP. So let us first of all see how the object is resting. It is resting on HP with one of the short edge normal to BP. So very obviously friends that the top view is seen as an equilateral triangle with side equal to 30 mm. So friends, let me mark the top view of the prism, an equilateral triangle of side 30 mm. So this is 30 mm. And here we'll name these corners as A, B and C. Let us obtain the center of this triangle by bisecting any two adjacent sides. So if we bisect them, the point of intersection of these bisectors will give you O, the center. Friends, in the front view, you know very well, it looks like a triangle. It appears as a rectangle in the front view. So friends, I will take the given height of the object and through these points I obtain the front view which is a rectangle. So to start with friends, when you are making the drawing, you will show all these lines very thin to start with. So friends, let us mark this, and before that let me mark the height of this prism which has got 60 millimeter height. So this is ABC. If you write this verticals through this will be A dash, B dash, and this is C dash. The axis O is here, so you can just write a line like this, the axis, and here you can mark O dash, the center of the top face, and here O1 dash, the center of the bottom face. This is A1 dash, B1 dash, and this is C1 dash, and double marking to be done for all the edges AA1, BB1, CC1. So double marking will be done in the top view only for the prism, cylinders, cubes only, and nothing else. So friends, this is how the object looks in the front view when it is placed on its triangular face on HP. And here you can see here friends, this side AB is perpendicular to VP. AB is perpendicular to VP. One of the shorter edges perpendicular to VP. Then friends, let us draw adjacent to this figure the development, assuming it is not cut by any section plane. Very obviously, for this triangular prism, you are going to get a rectangle of length is equal to 30 plus 30 plus 30, 90, and height is equal to 60 millimeter. So friends, adjacent to this front view, I am going to write a rectangle having height is equal to 60 mm, this is 60, and width is equal to 3 times 30, that is 90. So this is 30, this is 30, and this is 30, and here we mark like this has 30, that is the measurement of a very shorter edge is 30, and the total length is 30 into 3, 30 times 3, it is 90. If it is a square, we get 30 into 4, pentagon 30 into 5, hexagon 30 into 6, so on. So this is how the development of the lateral surface looks when the solid is not cut by any section plane. Now let us move on to the section plane. It says section plane which is normal to HP. Whenever any section plane is normal to HP, means perpendicular to HP, this is seen as a line in the top view, whether it is parallel to VP or inclined to VP. This section plane is seen as a line in the top view, means below the XY line. But how does it pass? He says prism at a distance of 10 millimeters from the axis, and it is inclined at an angle of 60 degrees. So friends, the section plane is passing somewhere here. I'll remove this portion to accommodate. So it is passing through a distance of 10 millimeters from the axis. This is O1 is the axis at a distance of 10 millimeter. So that distance can be seen only in the top view. So from here, I am going to mark a line, that is a section plane inclined at an angle of 60 degrees to VP. You can see here VP, and it is cutting this solid. So these are the two places where it is cutting the solid. And friends, very obviously, we are going to retain this part for the purpose of development of the lateral surface. So this smaller part is thrown away. And friends, you can see here, the developments are always drawn to true side. This concept is very essential because we never make any development for the reduced length. So here friends, whatever these edges I have shown here, they are all having true length only. And friends, you can see here, when the object is cut like this vertically, it is going to cut both the top face is ABC, and the bottom face A1, B1, C1. So friends, here you will have 2 points, here you will have 2 points, 2 for the top edge, 2 for the bottom edge. Here also 2 for the top and 2 for the bottom. Totally there will be 4 points. The next point is how to mark these vertical edges, whether to start from AA or BB or CC, etc. And remember friends, whenever you are marking these vertical edges, you should always mark the vertical edge, any edge that is totally removed from the section plane or which is not existing there. Friends, if you observe the top view, you can see here, in the portion retained for the development, the portion BB is thrown out. That is, this vertical edge and this part is not existing. So it is compulsory or it is mandatory to start from the vertical edge BB only. You may ask me, sir, what happens if I start from AA? Friends, what happens? You can practically do at home with the same example. By taking AA, the development you get here will come in 2 pieces. So it is very essential that you have to start from this edge B that is removed. So it is ABC, B, C, A, B. This is how we mark in this development. So this is going to be B1, this is C1, this is A1, and this is B1. So remember, the starting and the last stage should be same. That means when you fold them, these two should come together. If it is starting from A, ending should be A. If you are starting from CC, ending should be from CC. Friends, we have located the vertical edges. Now you have to transfer these points. That is, where the section plane SS, which is inclined at 60 degree and passing at a distance of 10 millimeter from the axis. This is 10 mm. That is parallel to this, you should take 10 millimeter from the axis and mark that. And let's see friends, it is cutting the edge AB at the top, A1 at the bottom. Let's complete top portion first. AB, it is cutting the top edge AB at a distance of so much from B. Measure this, take the measurement, mark this on AB near to B, on AB near to B, on AB near to B. So this portion what I have marked here is that gap, on AB near to B. Friends, similarly on BC nearer to B, these two will have the same dimension, on B nearer to B, BC nearer to B. BC nearer to B. Remember friends, whatever the distance I have marked here, say it is M, it is same as this M. M, same length they will have. And likewise friends, these are the 2 points you have got in the top edge, top edge say. So similarly for the bottom face, it is cutting A1, B1 at the same distance, A1, B1. This gap is same as M. So it is on A1, B1 nearer to B. A1, B1 nearer to B, that is same distance. Or you can simply write a vertical line from there and get this point. Friends, this gap is also M. So these two will have the same dimension. Similarly, friends, here on B1, C1 nearer to B, on B1, C1 nearer to B, same distance. We can just extend that and obtain that point. This is B1, this is the point you have got. So friends, totally, how many points you have got? 2 on the top surface, 2 on the bottom surface. And in all the prisms, pyramids, cubes, tetrahedrals, we have to join them by straight lines. So friends, I am going to join all this now. So I am going to join from here. And again, this portion I am going to join. And friends, now we should know which are the lines to be retained and which are to be shown by thin line. Friends, here you can see, if you mark this as 1, 2, 3, 4, say this is 1, this is 2, this point and the base is 3, and this point is 4. 4 points are there. So on BC side, you will have point 1 and 4. So this point is going to be 1 comma 4, and the other side is going to be 2 comma 3. 2 comma 3 will be on the other side. Friends, here now, which are the edges that are retained? See friends, here only BB is removed. So the edge CC, edge AA, they are totally retained in the development. So I have to show AA by full line. I have to show CC or C1, C1 by full line. And friends, these 4 points are there not to be joined. 1 to 4, 2 to 3. So friends, this rectangle have shown 1, 2, 3, 4 is the development of this part P, the development of this lateral surface. Friends, you can see here, whether to show this BB here, friends, the part or the longer edge BB is totally removed from the solid. So we should not show this in thick line or visible line. This is to be shown and retained by thin line. And when this is not existing, even this BB is not existing. When BB are not existing, these connecting lines also not existing. So this complete rectangle 1, 2, 3, 4 will give the development of P. Development of P. That is the development of the lateral surface of the larger part, this part which I have darkened is this figure. Friends, I hope the presentation was useful to you, and if you like this video, please don't forget to share with your friends. Have a wonderful day. Thank you.